Hello and welcome to this lecture where you are going to continue understanding the calculations for adjusting the weights. This graph shows the sequence of steps that we need to perform. First, we apply the sigmoid activation function and then we calculate the partial derivative, which you learned in the previous lecture. When we have the value of the partial derivative, we can calculate the delta parameter, which can be considered an auxiliary variable to help in the calculation of the gradient. In other words, we need this parameter to know in which direction we will update the weights. Returning to this graph, the weight is on x-axis, which is represented by the letter W, and the error is on y-axis. These calculations will indicate the directions of the weights update, avoiding the local minimum here and moving towards the global minimum here. Now let's see the calculations in detail. And the first one we need to do is the delta for the output layer. And only after that we will do the delta for the hidden layer. In the first phase of the neural network, we perform the feed-forward process, which data flows from the input layer to the output layer, from left to right. Now, we are starting the reverse process. We will update the weights starting at the output layer until we reach the input layer, from right to left. Now, let's see the calculations step by step. We are considering the first row, 0 and 0, and we already have the values of the sum function and the activation function. Just a reminder that the activation value is the prediction of the neural network. Now we can apply this equation. Delta output equals the error times the sigmoid derivative. We will apply that equation to extract the derivative value, sending as parameter the sigmoid value. First, we can get the error, the expected output, 0 minus the prediction, 0.406. The error is minus 0.406. Now we can calculate the derivative. We send 0.406 and we get as result 0.241. Just a reminder that this equation is being applied. Now we can calculate the delta outputs, error times the derivative. The result is minus 0.098 for the first row of the dataset. Now we need to move on to the second row, as you can see here, 0 and 1. And we already have the values here, the error, the expected outputs, minus the prediction. When we send the activation to the equation, the derivative is 0.245 and the delta outputs, the error times the derivative. The delta for the second row is 0.139. Now we need to move on to the third row, 1 and 0, and you can see all the calculations here. Then we move on to the fourth instance, 1 and 1, and you can see the corresponding results. I encourage you to pause the video if you want to check the values in detail. This is the first part of the calculations. Now we have the delta values considering the output layer. Now we can move on to the calculations regarding each one of the neurons in the hidden layer. We already have the delta outputs for the first row, which is minus 0.098, and we are considering the first row 0 and 0. We already have the derivative values 0.25, and now we can apply this other equation. Delta of the hidden layer equals the derivative sigmoid times the weight times the delta output. So we can get the derivative sigmoid 0.25. Just a reminder that we send the sigmoid value to the derivative equation, and we will get as a result 0.25, and we are multiplying it by the corresponding weight by the delta output for the first row of the dataset. The result here is 0, but of course it is not actually 0 because I am considering only 3 decimals. Now we need to calculate for the second neuron the derivative times the corresponding weights times the delta output. The result is 0.022. Then we move on to the third neuron, the derivative times the weights times the delta output. The result is minus 0.004. In this column, we also use the same value, the delta output. Now we need to perform the calculations considering the other rows. We can see here 0 and 1, the second row, the corresponding derivatives, and the equation. Just a reminder again, you can pause the video to check the values in detail. Let's move on to the third row, 1 and 0, the corresponding derivative values, and all the equation. And finally, we move on now to the fourth row, 1 and 1, and you can see the derivative values and all the calculations. And this is the step needed before updating the weights. And in the next lecture, you will learn the last step in order to update the weights. See you there!